Lesson 12.5, we go back to the rules of exponents. Now, I'm going to caution you to make sure you have these down for notes because these are similar to the rules that you were mixing up when we started the chapter. So, the first rule we're going to talk about is the powers of products. The power of a product property is to find the power of a product. You need to find the power of each factor and multiply it. So in our first example, it says 2x, and we want to cube that term. Notice that we have the parentheses around here. So what's being cubed is what's inside the parentheses. Okay? Now also we can think of what's inside the parentheses as two separate terms. So if we're using that kind of logic, we can say that 2x cubed is the same as saying 2 cubed times x cubed. Okay, we're going to cube the terms inside of the parentheses. So when you do that, then we can go ahead and we can multiply out our value here. 2 cubed, that's 2 times 2 is 4 times 2 is 8. Ooh, that's ugly. Let's change that. I'm going to write it over to here instead. 2 cubed is 8, and then we can't do anything with our variable, so our final answer would be 8x cubed. So the term 2x, when we cube it, will result in 8x cubed. So if we apply that same rule here, we would have that each term inside of here, this might be a better visual for some of you, more like a distributive kind of routine here. So each term, I would have negative 5 squared times y squared. Again, the numerical value can go ahead and be simplified. So negative 5 times negative 5 gives you a positive 25, and we need to leave our variable term as is. So that answer would be 25y squared. So that's when we are multiplying. That's the product inside the parentheses, and then we are using the power of product property. So next we'll go ahead and we will talk about the quotient property. Quotient meaning division. This is to find the power of a quotient, find the power of the numerator and the power of the denominator, and then divide. So again, I'll use my distributive mapping there to show you. That means everything inside of the parentheses is being is to the seventh power. It's to the seventh power. So I could change this and I could write it as it's going to be m to the seventh divided by n to the seventh. Now I don't have any numerical terms there and I don't have any like terms. So that would actually be my final answer. M to the seventh over n to the seventh. We'll do that same thing in our next example. And so I would go ahead and split up my terms, negative 3 to the fifth, and also k to the fifth. I have a numerical value though, so I can go ahead and simplify that. So negative 3 to the fifth, I can use my calculator. I know that because it's a negative and it's to an odd power, it's going to stay negative. And then 3 to the fifth would be 243. And then I cannot do anything to my variable expression, so it would be negative 243 over k to the fifth. So now the new property we're going to talk about is a power of a power. And this is also referred to as raising to a power. We already have an exponent here, 10 to the third, or 10 cubed, but we're going to raise it to the third power, or raise it and it's going to be cubed again. Now here is where things get a little tricky, and this is where you've mixed things up in the past. So be careful. I'm even using a yellow caution flag here. When I have a power raised to a power, that is when I go ahead and multiply. Okay? Now, if I worked that out, it would have been 10 cubed times 10 cubed times 10 cubed. When we do 10 cubed times 10 cubed times 10 cubed, you will see we have the same base, So we could add the exponents. When I add the exponents, I would come up with 10 to the 9th power. Now, if we just apply the property, however, I can shorten my steps, and if I'm raising to a power, I can just go ahead and multiply those exponents. So I would end up 3 times 3, and I would get 9. This is your Santa Claus moment, seeing how it works. This is where we want you to get to, where it would just be applying the property. So if I apply the property in this next one, I got pretty busy, so I'll put a little squiggle in there. I would say P, and I have P is the negative 4, but it's raised to the 5th power. So using my property, I will multiply my exponent. So I get P to the negative 20th. Now I have to apply one more rule of exponents, or definition of exponents, and I am not allowed to have a negative exponent. Excuse me. So what I need to do, if it's negative, I need to go ahead and change that to its reciprocal. So I'm going to put 1 over P to the 20th power. Or I'm adding 20 to the bottom when you're changing your exponents that way to get that positive exponent. So 1 over P to the 20th would be my final answer there. One more time, when it's a power of a power property or using the raised to a power, we are going to multiply. We did not multiply before, we're multiplying now. Santa Claus moment would show you the same base. Adding it, you would get to 10 to the 9th, but just as you learned when you learned multiplication back in 1st and 2nd grade, instead of adding the same number 3 different times, you would just multiply. So that's where you get to the 10 to the 9th. So our final example is using it in a word problem. So our word problem is about the world's tiniest book. So as you can see, we're going to have a negative exponent because this is tiny, tiny, tiny. So the square pages, and this is important, they're square pages. The square pages of the world's tiniest book are about 2.5 times 10 to the negative 3 meter on each side. So we're going to figure out what is the approximate area of one of the pages of this book. Don't let this scare you. We're going to use the approximate is because we don't have an exact measurement there, right? So first of all, remember there is a special formula for area of a square. When we're doing an area model, we always say length times width. But when we're talking about a square, every side is the same length. So that formula is side squared. And that's the one I'm going to push you to use today because it fits in with our lesson. So area of a square equals side squared. So we know one of the sides. One of the sides is 2.5 times 10 to the negative 3. And we know that that needs to be squared. This is our side. This whole expression here is our side, and that needs to be squared. So applying our rules, I know that means that that's 2.5 squared. And again, I'll show you that distributive. All right, so that's 2.5 squared times 10 to the negative 3 squared. Okay, our numerical value here, we can go ahead and multiply out, and 2.5 times 2.5 would give me 6.25, and yes, of course, you could use a calculator for that. And then I'm going to apply my property. I have a power raised to a power, so that said that I'm going to multiply. So that would be 10 to the negative 6. So at that point, I could say that the area is about, because we had that approximation, the area is going to be about 6.25 times 10 to the negative 6. Okay, they don't ask me to go ahead and finish that off. We could, because we're using a power of 10, so we know that means just dinks, and we're at a negative 6, so I could actually work that out. but they're not asking you for that in the textbook, so we'll skip that part for right now. So the original one, they gave it to me with an expression with a negative exponent, so I will leave my answer as an expression with a negative exponent. All right, and that finishes off the new rules of exponents that you've learned in 12.5.